Now let's size the overcurrent protection device in the primary side when the full load current of the transformer is less than 2 amps. And then remember, you always have the option, if necessary, because the overcurrent protection device blows or a circuit breaker fuse should open up during the energizing of the transformer. If it's a control transformer, you can go over to 430.72C4 and use 500% to increase the size. Now notice in the illustration, the transformer is 0.8 kVA, 480 single phase, primary is 2 wire, the secondary is 2 wire. And of course the equipment ground, and you could look that up in 250.30A5 exception 3 where they can tie through. And then the system bonding jumper is 250.30A1 exception 3. So look at those two sections to obtain that information. Now your control circuit is a class 1, class 2, or class 3 as defined in 725.3 of the NEC. If it's a class 1 circuit, you're referencing 725.41 A or B for either power limited or non-power limited. Class 2 and class 3 circuitry you'll find in 725.121, and those outputs that you could kind of get a review of would be in our table 11A and B to chapter 9 in the NEC. So kind of keep that in mind, and notice in the primary overcurrent protection device, the full load amps is 300% to start with from table 450.3b, based upon the full load current being less than 2 amps of the transformer. And if need be, we could use the 500%, again referencing 430.72 C as in car 4. Now this is the information that is given to us in the illustration. Of course, now the EMT you see there is used as an equipment ground, and also an equipment ground is pulled inside. So you kind of have redundant grounding there as permitted in 250.118 in the NEC. Now with this information given in the illustration, next we're going to perform the calculation to determine the size of the primary overcurrent protection device in this figure 20.11c.